First of all, we're asked to calculate the volume of this prism, and that volume is equal to the cross-sectional area times the length. That's true for any prism. So what do I mean by the cross-sectional area? Well, I mean this triangle here. That's the bit that's being repeated. So if I can work out that area and then times it by 11, then I'm done. So the area is just a triangle. It's going to be a half base times height, so a half times 10 times 6, and then I'm going to times that by this length, 11. And I can work that out. Well, I could do it without a calculator. A half of 10 is 5, 5 times 6 is 30, 30 times 11 is going to be 330. Next, use trigonometry to show the angle FDC, that's the one that's been highlighted, is equal to 31 degrees, correct to the nearest degree. Maybe I should have done this before. I'm going to do it now. I'm going to draw the triangle more clearly in 2 dimensions and label it F, C, D. And this is the one I'm interested in. So I've got 6 centimeters here and I've got 10 centimeters here. I can use trigonometry, SOHCAHTOA. I'm gonna label the sides. So this one is the opposite and this one is the adjacent. So it's going to be TOA tan. Tan of the angle, I'm just going to temporarily call it x. Tan of x is equal to the opposite over the adjacent, so 6 over 10. And now I have tan x, it's just 0.6, so I need to do the opposite of tan to figure out what x is. And that's the inverse tan of 6 over 10. .963, which is approximately 31 degrees. Okay, I don't think I need to write anymore. I think it's clear that my x is the same as angle FCD. Finally, we're asked to calculate the exact length of AF, this one that's highlighted. Now, how can we do this? Well, to find lengths in triangles, we tend to use Pythagoras' theorem. So we need to be trying to locate a right-angled triangle. And here's one. If I draw this length and I go up like this, and then I draw this line in, I actually have a right-angled triangle. Let's draw it out. So the height is 6. I've got a right angle. Let me just label it A, F, and C. And I'm trying to work out what this is, this question mark, but I also don't know AC. But I can deal with that because there's another right angle triangle going on. And that is this one here. I've got here to here to here. That is in fact the base. I've cut the base into half. It is a right angle triangle as well. So this is 3D Pythagoras essentially. Okay, so I might just draw this triangle here. It's 10 by 11, and then this is the value I want to find, and I can use Pythagoras now. It's going to be 10 squared plus 11 squared, square rooted. Now note, it's asked me for the exact value of AF, so it's going to be 221 square rooted. Not sure if that simplifies. No, it doesn't. Okay, that's all right. But I can now write that here because that's a shared length between the two triangles. So I'm nearly done because if I want to find question mark, that's going to equal 6 squared plus the square of the root of 221 square rooted, which is going to be 36 plus 221, which is 257 square rooted, and I think that's actually going to be the answer. Yep, the exact length is simply the third root 257. There is a quicker way we could have done this question. If you become confident with 3D Pythagoras, you can actually just use the fact that the length is equal to a squared plus b squared plus c squared, where a, b, and c are the three lengths going on in your triangles. So it's just going to be 11 squared. I'm not proving this right now. 11 squared, but you can play around and look at the proof if you like, but it's going to be that, which would again give root 257. So that can be a quicker way, but to be honest, I just advise you take your time, because there might be circumstances where this, you need to find other lengths that are missing. So don't just think, oh yeah, I just find the three numbers, square them, and add them together. Okay, go with it a bit more slowly. I just wanted to show it because it can be useful, especially when you start finding the lengths of vectors, not something done at GCSE level, but done later on.